Lecture is going to cover some of the main points in chapter 12. And chapter 12 looks at cross tabulations and chi-square and other associated statistics. So crosstabs and chi-squares really compute and interpret probabilities and odds ratios from a cross tabulation table. It would describe some of the statistics available to assess the statistical significance and differences in conditional probabilities. And we won't have you hand compute any of these calculations, but I will show you in another lecture how to calculate these in SPSS. You've already calculated some of the conditional and marginal probabilities in an earlier chapter. If you remember those chapters from the beginning of the semester, we're going to talk a little bit more in depth about those things. So crosstabs provide a tabular display of the relationship between two categorical variables of nominal or ordinal scale. And so two different sort of categorical variables that have a nominal or ordinal scale. These tables show the joint probability distribution of the two variables, and they can be used to calculate marginal, joint, and conditional probabilities, which you have calculated by hand in earlier semesters, odds ratios, and various test statistics like the chi-square test, the Fisher exact test, and the McNemar test. And so you can determine whether these are statistically significant, if there's statistical significance in the distributions in the crosstab. Crosstabs basically are constructed by creating a table with each row representing one of the variables, and then you add the rows and the columns at the end. I'll show you an example of this. The crosstab can be used to estimate probabilities, and so basically here's an example of a crosstab, which is a 2x2. So basically there's two dichotomous variables. So either they have a health condition or they don't have a health condition, and they were exposed or not exposed. And so you would have numbers in each of these boxes, and then the totals would be A plus C, B plus D, and then the total exposed are A and B together, the total unexposed are C and D together, and then our total is all of them paired together. So those A's, B's, C's, and D's would represent a particular number in a data set. From the table, we can estimate marginal probabilities. And so you've done this previously. The probability of being exposed, the probability of being unexposed, and the probability of having the health condition, and the probability of not having the health condition. You have done these calculations already earlier in the semester by hand. We can also estimate conditional probabilities, which are the probability of falling within a specific category for one of the variables, given that someone has one of the other variables. So the probability of having a health condition given that you are exposed, that you had an exposure, the probability of having a health condition given no exposure. And so you can see these examples here that can be calculated by using a crosstab. You can do joint probability, and we've already gone over this, so I'm not going to spend too much time on joint probability. We've already covered sort of what that is. And from the table, you can also estimate odds and odds ratio. And so the odds of having the health condition among those that are exposed. So basically the number of those exposed that have health condition over the total number of those exposed, divided by the number with no health condition that had been exposed, and over the total group that had been exposed. And so the odds of having the health condition among those exposed is this number. The odds of having the health condition among the unexposed would be this number. And then your odds ratio would be A times D divided by B times C. And so that would be your odds ratio. Conditional probabilities and the odds ratio, the OR, odds ratio, are good measures of strength and direction of an association. Strength and direction, so just like in correlations, we want to know strength and direction, but we also want to know if it's statistically significant. And so the chi-square statistic, the x squared, is commonly used to assess statistical significance if we're looking at two categorical variables. So there are 3 assumptions to the chi-square test. The data are frequency data, so basically counts of the number of individuals within each category. There is an adequate sample size, so all expected cell counts must be greater than or equal to 5, and the measures are independent of each other. Computing the chi-square statistic, basically it compares the expected frequency with the observed frequency in each cell. And what we mean by expected frequency is we mean the number of observations in each cell of the crosstab table that you would expect to see if the 2 variables were not associated with each other. So the chi-square test can be calculated by hand. I'm not going to ask you to do that, so I'm going to skip through sort of some of this, the hand calculation of the chi-square test. But let's give an example of a scenario where you would run the chi-square test. So is there a difference in the exercise habits of male and female graduate students? So we look at the null hypothesis. There's no difference in the proportion of male and female graduate students who exercise, and there is a difference in the proportion of male and female graduate students who exercise greater than 3 times a week. So here is our table. You can see all of our data is put into here. We have 68 total people. And is the proportion of female students who exercise greater than or equal to 3 times per week different from male students? So female students who exercise 3 times a week, we have 12 out of 36. So 33% of female students exercised greater than 3 times per week, and male students, we had 19 of 32. And so the total male students was 32, so that is 59%. Is this difference greater than we would expect to find just due to chance? So basically, is this just due to chance, or is it actually statistically significant? So we would do the chi-square calculation. We would do that. We will do that in SPSS. You don't have to do that by hand. And so what we find is the chi-square is 4.62. The degrees of freedom are 1. So you can see how to calculate the degrees of freedom. The alpha level is set at 0.05, and the critical value is 3.84. And so because the chi-square is greater than the critical value, we conclude that the difference in the proportion of men and women who exercise greater than 3 times a week is statistically significant at 0.05. I will show you how to calculate on SPSS and interpret the chi-square in a separate lecture. There's 3 assumptions, remembering this for the chi-square test: frequency, adequate sample size, measures are independent of each other. And what if your data doesn't meet these assumptions? So if your data doesn't, you can use the Fisher's exact test. So if the assumption, like that we don't have, like number 2, that having an adequate sample size. So let's say we only have 4 people in a group, in one of the groups, you can use a Fisher exact test. And so generally we will also compute that in SPSS. And so I will also show you how to calculate that. The McNemar test can be used if the assumption number 3 cannot be met, that the measures are independent of each other. So basically, if there are variables in which they are non-independent, so if you had twin studies, if you had a pre-test, post-test of the same individuals, or you had matched cases and controls, those are not so those aren't independent set groups. Those are sort of from the same group. And so you could use the McNemar test to calculate those correlations. So in summary, crosstabs are an easy way to present the data in 2 categorical variables. The crosstab, you can calculate conditional probabilities and compare 2 different groups. The chi-square test is used to determine whether those probabilities are statistically significant. And if your data cannot fulfill the assumptions of the chi-square test, you can use a Fisher's exact test or a McNemar test. I will post a separate lecture on how to calculate those tests in SPSS and how to interpret the output that you receive.